welcome. If you found this is intended to be the second part of a series for using sum and difference formulas. Our sum and difference trig formulas are as such. We're going to talk about these a little bit, but hopefully this isn't the first time you're seeing this. One of the things that sum and difference formulas do for us, and oftentimes when we're just learning those, we get lots of problems like what I'm about to talk about. They allow us to find exact values of reference angles that are 15 degrees and 75 degrees. Whereas before, we could find the exact value of our trig functions of 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degree reference angles. Now we can add to that 15 and 75. So let's take a look at a couple examples of those. Okay, so sine of 105 degrees. If I was to draw a 105 degree angle, that would take me 75 degrees short of 180 degrees. So I could go ahead and rename sine of 105, and the way I do that is by splitting the quadrant we're already in, creating a 45 in here, and then in this case I need to subtract 30 degrees from that. In other words, sine of 105 degrees is equal to sine of 135 degrees minus minus 30 degrees. Okay? So now we need our sine of a difference formula. So we'll take a quick peek at that again. Sine of a difference is sine of the first cosine of the second minus sine of the second cosine of the first. So let's apply that to this. And I get sine of the first cosine of the second minus sine of the second angle cosine of the first angle. Now at that point you might want to draw the triangles to create these, or you may have these memorized. Sine of 135 degrees is 1 on root 2, or root 2 on 2. Cosine of 30 degrees is root 3 on 2, minus sine of 30 1/2 times cosine of 135, that is negative 1 on root 2, or negative root 2 on 2. Again, you can draw the triangles and come up with those. This gives us square root of 6 plus square root of 2, and notice we get common denominators all on 4. Okay? Let's take a look at cosine of 195, another reference angle. So here this first problem we dealt with a 75 degree reference angle. 195 degrees takes me 15 degrees past 180. So now we have a 15 degree reference angle. I would call this cosine of, I'm going to split the quadrant that it's in, 45, so that would be a 225 degree rotation. And then I have to go backtrack 30 degrees. So minus 30 degrees. And I know how to handle that. Let's go back and review cosine of a difference. Cosine of a difference is cosine plus sine of the two angles. So this becomes cosine 225 cosine 30 plus sine 225 sine 30. And again, you may want to draw the triangles here, but cosine of 225 degrees is negative 1 on root 2, or negative root 2 on 2. Cosine of 30, root 3 on 2. Sine of 225 is 1 on root 2, or root 2 on 2. Sine of 30, 1/2. So I end up with negative root 6 plus root 2 all on 4. And as you do all of these 15 and 75 degree reference angles throughout our entire rotations, if you've done those, or if you were to do those, you will note that all of these end up as either plus or minus root 2 plus or minus root 6 all on 4. Of course, those are reversible. And every one of those, whether it's sine or cosine, ends up that form, to the point where it would be kind of nice if we just had a rubber stamp that looked like this, and then we could just come back in later and fill in those values as appropriate. Okay? So, embarrassed to say, for 20 years of doing this, every year we've spent a day or two working with these 1575s, and the mathematician in me just kept grinding through. It's not that bad to do, and it's probably good trigonometric gymnastics. It's probably good for us. At the same time, when we see patterns like that, we ought to just take a little bit of pause and think about that. So here is the thinking, the super shortcut on these, and it applies some understanding rather than memorizing. What we would have to memorize is just the rubber stamp portion of this, the root 2, root 6 on 4. And then we got to have a little bit of understanding about trig functions. So let's take a look at sine of these angles. So if we consider sine of theta. Now the graph of sine looks like, just the first period of graph of sine looks like this, where this is 360 degrees, 180 degrees. So as we tour around, that's not too bad. As we tour around, sine of 0 is 0. Sine of 90 degrees is 1. Sine of 180 degrees is 0. Sine of 270 degrees is -1. And sine of 360 gets us back to 0. I know that sine is positive here. Positive here. It's between 0 and 1 in both of those. It's negative here and negative here. So as I start touring around here, I hit, let's say, 15 degrees. I know that my value is close to 0 and it's positive. So I would define that position as a little positive value. And then I hit 75, where I'm getting close to 1 but still positive. That would be a big positive. As I move into quadrant 2 here, the angle that creates that should be close to 1, big, and still positive. As I move over to my 15-degree reference angle in quadrant 2, I'm close to 0, little, and I am still positive. Now I move into a quadrant where sine is negative, but it's still close to 0. I would define this as little and negative. Big, it's getting, the value's getting bigger, although negative. That's a big negative. Here we're into a negative quadrant, but we're still close to -1. Big and negative. Little and negative. Now let's consider what our stamp looks like. Our stamps would be, this would be great multiple choice questions, like what is the sine of 75 degrees? And the multiple choice questions or answers would be, for instance, A, root 2 plus root 6 on 4. And B, root 2 minus root 6 on 4. And C, negative root 2 plus root 6 on 4. And D, negative root 2 minus root 6 on 4. So if I'm going to classify each of these angles as big positive, little positive, why don't I come back and classify each of these to go along with those? In other words, look at A. I have positive root 2 plus positive root 6. That is positive, and it's the biggest value I'm going to get. This is big positive. This value, B, when root 6 is negative, that ensures that my numerator is going to be negative, but since root 2 is positive, they drag each other down. This is a little negative. Likewise, when root 6 is positive, that's the dominant term in the numerator, we're going to end up with a positive, but because the signs are conflicting, negative, positive, they drag themselves down and give us a little positive value. And this would be a big negative value. Therefore, at this angle, negative 75 degrees, The sine of negative 75 degrees is big negative. How do I make it negative? There. How do I make it big and negative here? Let's go sine right here. Little negative. If I start with my rubber stamp, root 2, root 6 on 4, little and negative. To ensure it's negative, to ensure it's little, those need to be in conflict to get them closer to 0. And there we have it. That works all the way throughout. Okay, how does that compare to cosine? Let me back up onto this. Let's go back here. Let's take a look at cosine. The graph of cosine, y equals cosine of theta, looks like that. And now, as we tour around our cosine graph, cosine starts at 1, goes to 0, goes to negative 1 over here, goes to 0, and comes back to 1. Cosine goes from positive into a negative quadrant. As we can see, it goes from 0 to negative 1, into a negative quadrant, and back into a positive quadrant. So as we tour around cosine, at this position, we're positive and big. We're close to 1. This is a big positive. Here we have a little positive. Now we move into a negative quadrant. At 105 degrees, cosine would be negative and little. That's close to 0. Little, negative. And here we are big negative. Out here we are still negative and still big. Big, negative, close to negative 1. Now we're little, but still in a negative quadrant. Little, negative. We're positive, but little, little positive, close to 0. And here we're big and positive. So if you were asked, for instance, the cosine of, let's go 100, do we do 105 degrees? Let's go 105 degrees. 105 degrees, that gets me to right here where we're little and negative. Root 2, root 6 on 4. Let's ensure that it's negative. Let's ensure that it's little. And that is it. That's pretty slick. If only that could work with tangent. I've given you a slight preview of that. Let's take a look at tangent. Tangent, negative 15 degrees. Let's draw it. We are right here. In order to do this the long way, we would split the triangle, create a 45. So I could get to negative 15 degrees by going negative 45 and then going back positive 30. So I could treat this as tangent of negative 45 degrees plus 30 degrees. Of course, that's negative 15. Let's jump back a couple of slides and look at our tangent of a sum formula. Tangent of a sum is the sum of the tangents over 1 minus the product of the tangents. Sum of the tangents over 1 minus product of the tangents. Or, one more time here, sum of the tangents over 1 minus the product of the tangents and I'm going to do this from memory. Tangent of negative 45 degrees is negative 1 plus tangent of 30 degrees is 1 on root 3 or root 3 on 3. And this is all over 1 minus, it would just be this guy, tangent of 45, negative 1 times this guy, root 3 on 3. So I get negative 1 plus root 3 on 3 on 1 plus root 3 on 3. At which point I might be tempted to multiply top and bottom of this by 3 to get rid of the compound fractions. So Let's go ahead and do that. I get negative 3 plus root 3 on 3 plus root 3. Let's go ahead and use the conjugate of the bottom to rationalize the denominator. 3 minus root 3. 3 minus root 3. In the numerator, I get, is this correct? Yep, I get negative 9. I get plus root 3 and plus 3 more root 3's, plus 6 root 3's, and I end up with my last term, root 3 times negative root 3 minus root 3. Denominator a little bit easier. I get 9 minus 3. So I end up with negative, whoops, got a mistake here. I'll bet you caught that. My last term, root 3 times negative root 3, just negative 3. I get negative 12 plus 6 root 3 all on 6, or I get negative 2 plus root 3. And after we do a whole bunch of these, we start learning that all of our tangents of 15 and 75 degree reference angles end as plus or minus 2 plus or minus root 3. So we have another stamp. I could just have a rubber stamp that started like this for my tangents, and then I just have to come back and fill in the signs. So let me clear out some space here, and let's take a tour of tangent graph. I need some music playing here or something. So let's take a look at what our tangent graph looks like and see if we can use our big positive, little negative again. Okay, that should give me enough room. So y equals tangent of theta. Hopefully by now we're pretty well versed in this. At 90 degrees we're asymptotal. At 180 we're back to 0. At 270 we're asymptote. And at 360 we're back to 0 like that. So here would be 180 degrees. Here would be 360 degrees. So as we tour around tangent, we start, as more circle yet, we start at 0, and then we move toward infinity. And this is a positive quadrant for tangent. This is negative. This is positive. This is a horrible fourth quadrant circle, negative. But as we move toward infinity in the first quadrant, we go from little positive to big positive. At 180 degrees, we're 0. And now as we're coming up along here, we are now big and negative. So positive or negative, but it's positive in first quadrant, negative in second. We are here big and negative. Little in a negative quadrant. Little close to 0 in a positive quadrant. As we move beyond 180 degrees, we start getting bigger and bigger, approaching infinity in a positive quadrant. So we are big and positive. Here we are big, but negative in here. We're in a negative quadrant for tangent. Little and negative. So if I asked what is the tangent of this angle, assuming that's a 75 degree reference angle, so of 180 and 75, 255. If you were asked tangent of 255 degrees, we locate that here, 75, we'd say, oh, that's big positive. 2 root 3, they must both be pluses. How about, ooh, that's my black pen. How about we take a look at one more of those and apply our big positive, little negative technique. Let's take a look at, for instance, this angle right here, where we're to find tangent of 165 degrees. Tangent of 165 degrees is little and negative. To ensure it's negative, my bigger term, 2 is bigger than square root of 3, must be negative. To make it little, I want conflict, so the root 3 is plus, bringing it down closer to 0. Just a great technique if you have a whole lot of these problems. And Not that the process going through isn't valuable, and is this going to solve all of them? For instance, if I had an angle right here, does this tell me what it is? No, it's got to be 15-degree and 75-degree reference angles. That is critical to use this, but pretty useful. Hope that's helpful to you. Stay tuned. If you just joined us and you didn't see the first of this series, you may want to search YouTube for the first of this series, same title. We'll go back here. The title of the first one would be Trigonometry Sum and Difference Formulas. This is just our part 2. You may want to check out part 1. Thanks for joining me, and stay tuned.